Okay, so we're going to spend some more time on limits today. Today we're going to talk about something called a right hand and a left hand limit. Nope. No, that's not a typo. The negative sign is not supposed to be in front of the A. We're not taking the limit as x approaches negative A. What that says is the limit as x approaches the number A, whatever that is, from the negative side. Okay? What? Well, we don't know what it's going to be. Okay? And then we could also take this and flip it around if you wanted to, and I won't write this all out because I'm sure you can figure it out. We could also do the limit as x approaches the number A from the positive side. And when you're approaching it from the negative side, that's called a left-hand limit because it's coming from the left side, right? And when you are approaching a number from the positive side, that's called the right-hand limit because you're coming from the right-hand side. So let me explain to you what that means. You have that copy down? No, not yet. And then let's figure out the overall limit as well, okay? So what number is this graph approaching if you had it typed into your calculator and you're looking at a table and you were looking at numbers less than 2, what y value is the graph getting closer and closer and closer to?
3.
Oh, dang it. Yeah, I was trying to have that go closer and closer to 3. You guys see that? From the left-hand side, if I'm going along the graph this direction, then I'm looking at the values that are less than 2. My y values are going to be approaching 3. Do they ever get to 3?
No.
No. There's a hole in the graph there. Okay, so that would be an error on your calculator. What if then you looked at the numbers on the other side of 2? Now you're looking at the numbers that are bigger than 2. What y value are those getting closer and closer to? I was kind of going for 1 there. Yeah, does that make sense? So now if I look at the numbers that are on the right-hand side of 2, as those get closer and closer to x equals 2 from that direction, now they approach the y value 1. Okay? Am I doing anything crazy? Because it's important that you yell at me if you don't understand. Okay, so that one equals 1. Okay, so now if we look at the overall limit, what would you say the answer is? Your silence, so you took the average of them?
Yeah.
I like your silence better. Doesn't exist. Okay? Because it's doing something different from the left-hand side than it is doing from the right-hand side. That means we say the overall limit doesn't exist. You can't just take the average. These two pieces of the graph would have to meet for that to work. Yeah. So let's take a look at this one, for example. What would you say the limit as x approaches 5 from the negative side is?
2.
2. Because if I go to the negative side, the left-hand side of 5, and follow along the graph, my y values are getting closer and closer to 2. Okay? What is the limit as x approaches 5 from the positive side of g of x equal 2? Same thing, right? Because these are both getting closer to the same y value. Okay? So that allows us to say what is the overall limit as x approaches 5. That one would be 2. Okay? But then the wacky part of this is, what is the value of the function when x equals 5? 1. Because this dot right here at x equals 5 matches up with the y value of 1. Okay? So it's okay for the value of the function to be different than what the limit is, but it's not okay for the left and the right-hand limits to be different. So you can have a hole or a discontinuity, somebody used that fancy word, I think yesterday, in the graph right here, and you still have an overall limit for the function, but you can't have what's called a jump discontinuity there and still have the limit, overall limit exist. Okay? Make sense? All right. So that means we can say that the limit as x approaches a of a function equals some number if and only if the limit as x approaches a from the negative side equals that number, and the limit as x approaches a from the positive side equals that number. Okay, so the right and the left-hand limits have to be the same in order for the overall limit to exist. All right, we good with that?
Yeah.
All right. All right.
Where we come now?
Don't even talk about that. All right, let's do another one. Maybe you can do this on your calculator and tell me what you come up with. Find the limit as x approaches 0 of 1 over x squared. Any guesses? 10,000?
10 piece is right.
10,000 you're going with?
Yeah.
Anybody disagree? Anybody find something different? Yeah? What do you get?
Well, mine is, it's at 1 million right now.
It's at 1 million, okay, so 10,000 is not big enough, so if we go 1 over x squared, and then we go to the table, that's, as I get closer to 0, that's 1 with 8 zeros at the end of it. Is that about 10 million? Okay, well yours says 10,000, but you're going by a smaller thing, right? Or not as small of a thing. So if you change your table, so that you go by, let's start at 0. If you change your table so you go by 0.00, how many zeros should we go by? 3 zeros and a 1. Okay, and then we look at the values here. This one right after it is 1 times 10 to the 8th is what that means, and right before it is 1 times 10 to the 8th. So does that mean that the limit is 1 with 1, 2, 3, 4, 5, 6 zeros, or 8 zeros? So does that mean the limit is 100 million? Why is it infinity? Right, it gets higher and higher and higher. So we could change this to go by 0.000. Is that enough for you? And then if we look at the table now, it's even bigger. Okay, we can throw more zeros on the end there. And if you look at the graph, you can see why. What's happening right at 0 as we approach 0, the graph is going up forever this way. If you approach 0 from the other side, it's going up forever that way. Okay, so that one we would say the limit is infinity. Okay, so you can have graphs or functions that have infinite limits. In other words, there really is no limit, but we'll just call it infinity. But you misspelled it. So we can't use it.
Didn't misspell, I said. Can't misspell it.
What's this vertical line called right here? Asymptote.
That's another point.
Okay. So we're going to use this as a definition. If you've got 6 different options here for this to work, if you have the limit as x approaches a of the function equal infinity, or what's another way you think you could get a vertical asymptote? The limit as x approaches the number could equal what else?
Negative infinity.
Negative infinity.
Point?
Good. 5 points for that one. That's a 5-point question for sure. Negative infinity. In other words, I could take this graph right here and toss a negative sign in front of it. And then now the graph is flipped upside down. So now the limit as x approaches 0 is negative infinity, but I still have a vertical asymptote, right? Okay. Or just for funsies, this is kind of redundant. I could have the limit as x approaches a from the positive side only equal infinity. Okay. Yeah, and if you want to see something that looks like that, then I would get rid of this squared. So if we delete that, and then look at that graph. Now if I look at the limit as x approaches 0 from the left-hand side, this piece is going to infinity. Okay. So I have a vertical asymptote there, or from looking at the graph, I could approach 0 from the positive side. Oh, I was doing it from the positive side, sorry. So we could also do the, I probably don't have to write all this down, but we could do from the negative side, or you could change both of those infinities to negative infinities, right? Any one of those things happen, then x equals a is a vertical asymptote. Okay? All right. So let's do. And by the way, we will have a quiz after section 2.3 whenever we get there. So be ready for that. Okay? I don't know when that'll happen, but just a little advanced warning.
No idea what's going on.
We're gonna learn anything.
All right, so let's take a look at a couple of one-handed limits. So we got a couple different ways that we can solve these on the desk. So we're going to try and find the limit as x approaches 3 from the positive side of 2x over x minus 3. There's a couple different ways we can solve these. We can go table, or we can go graph. Okay, you want to go table? Okay, so to do it by the table, I'm going to type that function in. It was 2x over x minus 3.
2x minus 3 over x. Sure.
2x over x minus 3.
Yeah.
That's 5 points away from 12. Okay, so now when I go to set the table, I'm going to start at 3. And I don't need to go by such small numbers. I'm going to just go back to 0.01. Okay? And so if I look at my table of values, you kind of have to use your noggin here a little bit. If I'm trying to figure out the value of the limit from the positive side, then do I want numbers bigger or smaller than 3? Bigger. Okay. So what is this? I go up this direction based on the conversation that we just had. What does it appear these numbers are doing? Increasing without limit. Okay, I'm guessing if we change this to 0.001, we'd get a better, bigger number than 602, and so forth. And you can confirm that by looking at the graph. It's the other way that you can do this. if I go to 3 right here, what's happening to the graph as I approach that from the right-hand side? Infinity. Okay, so I would say the answer to this is infinity. And then looking at the graph, or you could look at the table, if I approach 3 from the negative or left-hand side, the graph is approaching negative infinity. Okay, so what can we say is true about the graph at x equals 3? Got a vertical asymptote at x equals 3. What would you say the limit is as x approaches 3 from either side? Plus or undefined. These two are not the same, so the overall limit does not exist. You got one going up, one going down, so the limit as x approaches 3 does not exist because it has to be the same both times. Okay? Make sense?